Hello again. We're still with matrices. We're going to be working with determinants. In this case, it's going to be a 2 by 2. Next example, we'll do a 3 by 3 example. A lot of students, though, when they do 3 by 3 in determinants, they just plug it into their graphing calculator. I don't show them how to do that. It's not because I'm unfair, it's because I want them to learn how to do a determinant 3 by 3. Especially if you're in that math class, you should learn how to do it. Before I continue with this, I should say that in order to figure out a determinant, it has to be done on a square matrix. A square matrix is one that's even in dimensions. Example, this one's a 2 by 2. You can't find the determinant of a 2 by 3 because the dimensions aren't the same. You know, it has to be the same length as it does width. So 2 by 2, 3 by 3. Those are examples of square matrices. 2 by 5 is not a square matrix. 2 by 4 is not a square matrix. I think I already delivered that point, but with that said, here's the formula that we traditionally follow in order to figure out a determinant. And it's not terribly difficult. In fact, when I show my students, they tend to be a little bit happy because they think it's going to be brutal. Say, no, not until we get to a 3 by 3. That's going to be bad. But 2 by 2 is pretty pleasant. So I have this matrix, this imaginary matrix, this 2 by 2 with 4 elements, A, B, C, and D. In order to find the determinant of a matrix, you take A times D subtracted by B times C. And people ask, well, what do you use determinants for? Well, one is for calculating the area of a matrix, linear transformations. Finding the solution of a complex system of equations is another way. I'll have a story for that later on. It's actually true, and I never thought I was going to use this in real life. I mean, outside of a math class, but I did. I was actually pretty happy that I knew how to do that, which was really cool. I'll explain that later, though. So I've got this matrix here that I want to figure out the determinant for. Well, what I do in order to figure out a determinant for 2 by 2 is I take these two terms and multiply. Well, 3 times 1 is 3. And then I subtract the product of those two terms, 4 times negative 2, which is negative 8. Well, two negatives in a row make a positive, so it's 3 plus 8 equals 11. That's it. You can have a determinant that's positive or negative, that's perfectly fine. You can have, positive or negative. If you have a positive or negative determinant, you will have an inverse, which will help you solve equations properly. If you have a determinant of 0, though, you will not be able to find an inverse of a matrix, which we'll get to later, but I just thought that was pretty interesting. In order to find an inverse, though, you have to first figure out its determinant, and I'll apply it to solution set when we get to that point. But for right now, have a good day. We'll do 3 by 3 next. Goodbye.